llm-d installation and deployment is designed to be relatively straightforward. Installation is based on Helm charts, providing a familiar and customizable installation procedure. In addition, there is a QuickStart CLI, which provides an easy all-in-one deployment, including dependencies, prerequisites, and other features like samples and observability features. Since the installation is built for Kubernetes, it works on multiple targets, including Minikube and OpenShift. All of this is available in the llm-d deployer repository on GitHub. In the deployer repository, you'll find a QuickStart as well. Let's run the QuickStart installation. We've already installed the client dependencies. Since our sample application will download a model, we'll need an authorized Hugging Face token. We could spin up our own Minikube instance and run a development cluster, but this is an OpenShift cluster, so I'll simply log in. Next, we'll kick off the QuickStart installer and set the storage parameters. The installation is now installing some prerequisite infrastructure elements, including the gateway system setup, namespace, pull secrets, and a PVC to store models. It's also downloading the sample model from Hugging Face. After downloading the model, the deployer will install llm-d using Helm. Now that installation is complete, you can see several deployed resources. These include Redis for KV cache metadata, the model service controller, and the resources for the deployed model service, including the Inference gateway, the Inference scheduler endpoint picker, and prefill and decode deployments. When the deployment is complete, and the prefill and decode have loaded the model successfully, we can test out the new service. So we can now chat with our deployment, but what actually happened on that request? Let's trace the path of the request to understand what llm-d is doing. You can see how the architecture compares to the deployed resources. When the request is first made, it is received by the gateway. In order to route the request efficiently, the endpoint picker, based on Gateway API Inference extension, can process the request. The Inference scheduler can score the request on several factors. For example, this long request with many tokens will be designated for a pre-filled decode disaggregation. It can also look across the cluster and send it to the best node based on prefix or KV cache locality. Armed with information where to send the request, the gateway can send it to the correct decode pod where the routing sidecar will manage the request. Since the request is designated for PD disaggregation, the routing sidecar has sent the request for remote prefill. Once the prefill is complete, the decode will receive the result. When executing the decode, VLLM can pull the cache from prefill using LM cache and Nixel. Now that the request is complete, the result can be sent back to the user. Join the llm-d community. llm-d is open source under the Apache 2.0 license and available on GitHub. You can also find us at llm-d.ai.